I gave you the answers yesterday, included in the video that I forgot to post, and nobody emailed me about, so clearly we didn't need it. But it'll be posted today, as well as today's video. Are there any questions, comments, concerns anyone would like me to go over from anything I assigned yesterday? Yes, Luca.
What's your channel name?
Stephen Dweedoff. Same as my email, my school email. Go to YouTube, you search my name first and last. I'm the only Stephen Dweedoff. Make sure you spell it properly. I've had a whole bunch of students spell my last name D-O-W-I-D, and then they're like, I can never find your channel. It's E-D-O-F-F. Are there any comments, questions, concerns? The answers are also going to be in today's video because I'm recording right now and I'm showing the answers everywhere. So there's nothing anyone would like me to do. All of the ionic naming is easy. There will be no problems when I give you a quiz on this stuff. Because as was noticed by several people, if you take a look at the board, blocks C and D, my two science classes, you guys are going to be having a quiz, 2 quizzes for me in the next 4 days. I will not tell you when, other than to say that at some point in the next 4 days, not including Saturday, Sunday. So the next 4 days would be, because I don't exist on the weekend, Thursday, Friday, Monday, Tuesday. At some point in the next 4 days, you guys are going to write me a quiz. The first one's going to be Lewis and Bohr diagrams. You'll have to do a bunch of those for me. At this point, you should be comfortable with that. I've given you, I mean, yes, it was a little while ago, and if I had not been sick, the quiz would have happened already. But there's going to be a Lewis and Bohr diagram quiz. I will go so far as to tell you that one will happen before the weekend. And then after the weekend, you're going to write me a naming and formula writing quiz, including the stuff that I give you today, which is going to be on this page. Okay, so if there are no questions, I would like you to find this page, covalent compounds. Sometimes this gets done in grade 9, sometimes it does not get done in grade 9. It really depends on who your Science 9 teacher was. Technically speaking, I do not believe it's part of the official grade 9 curriculum, but it's so similar to all of the naming stuff we've just already done with the ionics. Lots of Science 9 teachers tossed it in there anyway. So, here we go. Covalent compounds. All the naming rules we've done up to this point have been exclusively ionic naming rules. So ionic naming rules are positive ions and negative ions. I can't say that it's a metal ion and a non-metal ion anymore because now we've got positive polyatomic ions. Where did my gigantic periodic table go? Where are you, giant periodic table? Ah, you're right there. Things like ammonium and hydronium. Both of those are non-metals. There's nothing metallic about ammonium. There's nothing metallic about hydronium. But when those things react, because they're positively charged, if they react with a non-metal or another polyatomic, that's going to be ionic as well. And so there's now naming rules for all of the ionics. The simple ionics, the metal, non-metal, the multivalence, when you have multiple ion charges, and now all of the polyatomics are fair game. All of that's ionic. Yes, Imparis. If it is ionic, so positive and negative, ammonium or hydronium would always come first. Whatever the positive ion is, if there's a positive ion and a negative ion, the positive one always gets listed first. The negative one always gets listed second. Today, we're going to look at the covalent compounds. And there's a few ways to identify the covalent compounds. We've talked about what covalent compounds are already. A covalent compound, when I gave it to you to start, I said, okay, covalent compounds are a non-metal and a nonmetal. Another way to identify a covalent compound is to say, or a negative ion and a negative ion. And there is actually another name, which we haven't used yet, for all of the covalent compounds. They get lumped together under one big name. It is the other science buzzword that starts with M that isn't mitochondria. Does anyone know another name for a covalent compound? 8 letters, starts with M. A molecule. Covalent compounds are also called molecules. Ionic compounds are not. Ionic compounds are ionic compounds. Covalent compounds are molecules, or molecules are covalent compounds. And so we reserve that name for these kinds of compounds. So they're molecules, or sometimes they're called molecular compounds. To be a molecule means you are made up of bonds that have shared electrons. And that only happens between negatively charged and negatively charged things. So, review. Let's start everything I've just said now. Let's start filling in the gaps. Covalent compounds are formed between negatives and negatives. Negatives. Generally speaking, those negatives are nonmetals. Both metals want to gain electrons. At this point, you've seen this. We've been doing Bohr diagrams and Lewis diagrams of ionic and covalent compounds, and we've seen that the nonmetals have space to fill. It's easier for them to gain 1 or 2 or 3 to stabilize than it is for them to give up 5, 6, 7, 8 electrons. They don't want to do that. They all want to gain. And so when you've got multiple things that want to gain, they end up sharing. And because of this, they don't bond the same way the ionics do. Luca, do I need to change colors? Do I need to change colors? No, you're squinting. I'll change the way. I'll get rid of orange. So, naming rules for covalent compounds. Here we go. I'll start with this guy as an example. I've got B2H4. Here are the rules for naming that thing. When they're covalent, everything's negative, whatever is left, and I don't mean like left behind, but the leftmost element. In this case, that would be the boron. The left element gets named first, or gets said first as part of the name. But I could easily have written this thing as H4B2. There's really no good reason why we wouldn't write one or the other first. And so in this case, if I wrote it as B2H4, the boron, the B, would get named first. In this case, the hydrogen would get named first. Whichever way it's written, however it's presented to you when it's a covalent compound, is how it's going to get named. You don't have to do any mucking around with that. And I'm going to remind you guys, we've said it a whole bunch, we'll say it again, so I've got hydrogen and I've got boron. If you take a look at the periodic table up at the back, actually there's 2 periodic tables up there. Boron and hydrogen. Hydrogen can show up in a couple different places. Hydrogen behaves as a nonmetal unless it's reacting with group 17. So this would be considered a covalent compound. Boron is in group, 13? Boron's up there next to carbon. It's a nonmetal. And so boron and hydrogen are going to form a covalent compound. So the leftmost element is said first. The right element, whatever it is given the suffix IDE, just like in the ionics. Whatever comes second is given the suffix "ide," unless it's polyatomic. And because the covalent compounds share electrons, they do not balance charges. So we don't have to care about what the charges are. As soon as you identify that we've got a negative and a negative, nobody cares about what the charges themselves actually are. Because of this, There's no balancing charges. There's no writing things in lowest terms. Like the ionics are easy. The ionics say I've got to react in lowest terms, and I need to balance the charges. The covalents don't do that. And so because of that, we bring in another tool. We bring in prefixes to tell us how many of each type of element are present to react. And so here's our list of prefixes. There are different prefixes that you might be used to seeing in the English language. There is a Greek set, and then there is a Latin set. Things like a prefix for one. If you have a one-wheeled bicycle, what do we call that? It's called a unicycle. Uni is a prefix that we use to denote that there is one of something. But if you have glasses that only have one lens, what do we call that? It's a monocle. So both uni and mono are prefixes that exist to tell us one of something. One is Greek, one is Latin. I don't know which is which, it doesn't matter. But that's why there's two of them. When we're looking at chemistry, when we're looking at one of something in chemistry, we use the prefix mono. If I'm looking at number two, sorry, there's two prefixes for it. Generally speaking, in science we use di, or in chemistry we use di generally, but the other prefix that means two of something is bi, which can get kind of confusing for reasons I'll show you in a second. Di is the one that we use when we're naming covalent compounds. 3 is tri. There's only one of those. 4, though, there's two of them for 4. There's quad and there's tetra. Tetra is the one that we use. Don't give away. Yes, you're right, it's there. 5 is? Sorry? Someone said it. It's penta. As in pentagon, or if you're into horror movies, pentagram. 6 is hexa. 7 is? Ooh, there's 2 for 7 as well. 7 is either going to be septa or hepta. Septa is Greek, hepta is Latin. We use hepta. Depending on the Disney movies that you're into, you might actually be more familiar with septa. My children are familiar with septa because they're big into Finding Nemo. And Hank the octopus has lost an arm, so he's actually only a septopus. And they call him that in the movie. Hank is a septopus. So my 4-year-old is all over the prefix septa. 9 is nona. 10 is deca. So these are the Latin prefixes to denote how many you have of something. And generally speaking, actually, when we're naming covalent compounds, this is what we use. As Angel just pointed out, and perhaps some of you noticed already, you do not have to memorize these as I've given them to you on the back side of the periodic table. But if you have memorized them, if you have a working understanding of them, being able to not flip back will save you a lot of time. Additionally, some of the alternate ones that I named show up as well. So for example, di is 2. It's the prefix that we use to denote 2 of something when naming covalents. The other one we talked about was bi, as in bicycle, a 2-wheeled vehicle. Bi is not one that we use for covalent compounds, but it shows up here anyway. We've got bicarbonate, bisulfate, bisulfide, bisulfite. So when you see bi, that's not one of the covalent prefixes that we're using, but it does show up in naming. Di is one that shows up when we're naming covalents, but it also shows up in the polyatomics. Dichromate. And so when we're naming these things or formula writing these things, we don't just want to look at the existence of the prefixes because they show up in a couple places. Dichromate, bicarbonate. Does it show up anywhere else? Dihydrogen shows up there. I think those are the only ones. But you've got to look at what the rest of the thing that they're attached to is called. So these are the prefixes that we use for covalent naming, and they're on the back of your formula sheet or your periodic table. We use these prefixes to tell us how many of each type of element react. The number of atoms of each type determines what prefix is attached to the molecule. There are rules for how we use the prefixes. Here they are. The first element only gets a prefix if there's more than one. It doesn't matter what the first one is listed. If there's only one, we don't use a prefix. The second element always gets a prefix, doesn't matter how many there are. So we never use mono on the first one, but we always use a prefix on the second one. Yes, Imparis. What about monoxide? It does. And I'll use an example of that in a second. That means the oxygen is not listed first. So the second element always gets a prefix. The first element only gets a prefix if there's more than one. Do not reduce to lowest terms when you're dealing with covalent compounds. They do what they want to do. So first example, we're going to go back up here to the top. And I've listed two here. I got B2H4 and H4B2. Chemically identical. 2 borons, 4 hydrogens, but because of how we've listed them, they're going to get named differently. What would the name for B2H4 be following these naming rules? Well, we go left to right. B is? Sorry? B, well, what is B? Forget the prefix. What's B? B is boron, okay? So there is no, like the ending doesn't change. B is boron. And I've got 2 of them, so we're going to add this prefix di. Is the printer not working?
It did it 20 minutes ago.
Oh, weird. So I've got 2 borons, so this is going to be diboron. I've got 4 H's. H is hydrogen, so because it's the second thing listed, its name gets changed to? Well, the 4 mean, yes, sorry. There's 4 of them, so let's add the tetra. Hydrogen gets changed to? No, hydroxide is when there's an H and an O. The second thing that gets listed gets changed to IDE. So hydrogen becomes hydride, yes. So this thing, B2H4, would be diboron tetrahydride. But if I took the exact same compound and I swapped the order on them, what would the name of this thing be? Well, H4 means I've got 4 of them, so tetra. It would be tetrahydrogen diboride. You betcha. Just however it's presented to you, as written, is how we name these things. So I've got 2 down here at the bottom as well. I'm going to add 2 more underneath them. So PI3 is going to be? There's only one of the P's. So because the first one only has 1, we do not use a prefix. So P is? Phosphorus. This thing is covalent because it's a nonmetal and a nonmetal. So I3 is going to be triiodide. The double I is allowed. And we say it like it's hyphenated, triiodide. The next one, N2O4. It's going to be dinitrogen. Because we have more than one, we use the prefix. Dinitrogen tetraoxide. The AO vowel combination is also allowed. We're going to tack 2 more on the bottom of this. We're going to add CO, something that all y'all should be familiar with. You should have detectors for this thing in your home. What is the name of CO? This is carbon monoxide. Even though there's 1 carbon, we do not use a prefix on the first one that's listed. I've got 1 O. The second element always gets a prefix, so this is going to be monoxide, no double O. We're allowed to double up the I's. We are not allowed to double up the O's. Otherwise, it would be carbon monoxide, and that would be weird. One more down here for you that's important to know. H2O, more commonly known as water. What is the chemical name for water? It would be dihydrogen. It would not be dihydrogen oxide. It would be dihydrogen monoxide. And this is an important one to know because it comes up every so often, usually around April 1st. A couple years ago, 2 Australian radio DJs hopped on their radio station on April 1st in the morning, and they made this big public service announcement. This was in Sydney, Australia. They made this big announcement. They said, hey, everyone, listen, your water has been contaminated with a chemical called dihydrogen monoxide. It is dangerous if taken in large quantities. If you breathe it in, it will kill you, which is all true of water. If you drink too much water, you can actually die. Your body is a great way of filtering all that out, so it generally doesn't happen, but you can overdose on water. If you breathe in water, you will drown. It will absolutely kill you. And so these 2 radio DJs hopped on and said, dihydrogen monoxide, it's infected your water. Everyone be aware. And as the general public lost their minds. They didn't pick up that it was a joke. They had all forgotten their Science 9, Science 10 covalent compound naming, and they started calling into their various cities in Australia, freaking out, concerned to the authorities that dihydrogen monoxide had been placed in their water. Those 2 DJs were fired for causing a nationwide panic about water being in their water. And it's a useful one to know, especially since April 1st is right around the corner. Flip the page. So that's naming. As written, left to right, using the prefixes for covalent compounds. Here is formula writing. The formula writing for these guys is very, very easy. If you can identify that you've got a covalent compound, that's the hardest thing, is identifying what kind of compound you have. Is it ionic? Is it covalent? Because on the quiz that I'm going to give you, I'm not going to tell you if it's ionic or covalent. I'm just going to take them all, I'm going to shake them up, I'm going to dump them on the page, and all the rules are going to be mixed together. There's going to be some ionic, there's going to be some multivalent, there's going to be some polyatomic, there's going to be some simple ionics, everything together, mixed. Your first task will be to identify ionic or covalent. Once you can see that you've got a covalent, it's really quite easy. Remember, covalent is negative, negative, or non-metal, non-metal. And if you're formula writing for this, and you've identified covalent, you just use the prefixes as they're written. There's no balancing, there's no reducing. You write it as the name says. If there is no prefix on the first element, there is only one of that element. Beneath here, I want to put 2 stars just to write down something I did just say. When you're formula writing for a covalent compound, there is no balancing. There is no reducing. Like when we're ionic and we're swapping and dropping, like if I have a charge of 4 and a charge of 2, I wouldn't, if you do that swapping, you have to reduce if it's ionic. Why? Because the ionics always bond, when they react to each other, they always bond to balanced charges and in lowest terms. So one of the examples that I gave you was like titanium oxide. Sorry? Covalents, why don't they? Because they're sharing, they are, by the order of the universe, allowed to arrange themselves in a bunch of different ways. And they just do. There really isn't at this stage, there isn't a great reason I can give you, other than the fact that we know that they behave this way, and so we just let them do what they're going to do. There are some quantum chemistry reasons for why they do what they do, but we're not going to get into it this year. You'll learn about it next year in chemistry. So, nitrogen trichloride. Nitrogen's a nonmetal, chlorine's a nonmetal. So we just use it as written. There's no prefix on the nitrogen, so how many nitrogens do I have? 1. When I have 1 of something, I don't write the number. Chloride is chlorine. How many do I have? 3. NCl3 and we're done. Sulfur hexafluoride is another one. It's just going to be SF6. And then dinitrogen tetrasulfide, it is just going to be N2S4. Something like this, we do not reduce. It just is the way it is. Totally unrelated. SF6 is actually a lot of fun. I want to show you a video here real quick of SF6. I'm going to pause this. Homework is this page, all of it. This is optional page. This is all of it. And this is mixed. So it's using all the naming rules we've looked at over the last 3 or 4 days. Good luck.